Hi everyone. I hope you can hear me loud and clear. Thank you for joining us today for the Diligence webinar covering Alteryx in higher education, specifically exploring campus utilization and campus optimization. Firstly, I hope you're doing well in light of the ongoing COVID-19 situation. Here in Singapore, we have the ongoing circuit breaker period where most of us are working from home unless providing essential services. I believe we have various versions of this across the different countries our webinar attendees are coming from. My name is Vignesh, and I'm in charge of business development at our Singapore office. Diligence Asia is part of the Diligence group of companies covering Australia, Asia, Europe, and the US. Diligence provides expert BI consultancy worldwide, as well as partnering with world-class product companies like Tableau, Alteryx, and Colibra to provide the best fit solutions and services to our customers. In Singapore, some of our customers are DBS, GIC, Singtel, and now, most recently, Ngee Polytechnic. Globally, we work with the Commonwealth Bank of Australia, University of Glasgow, University of Technology Sydney, Vodafone, Mondelez, amongst many others. I'd like to introduce some of my colleagues who help our customers succeed. Working with me in Singapore is Principal Consultant Colin Chang, and some of the key people behind our recent Alteryx successes. In the higher education space, Michael Evans and Iveta Sobotkova. Despite being spread out across our various offices, we're actually quite agile and share our knowledge and expertise with customers located in Singapore, Sydney, Mumbai, Prague, Frankfurt, and London. Allow me to hand over to Michael to share more about our higher education work. Michael, please.
Thanks, Vignesh, and thanks for joining us. I'd like to take you through a just brief introduction of Diligence, if I may, just to give you an idea of where the expertise really comes from. As you can see, and as Vignesh mentioned, we are a global reach consultancy. We have a range of targeted locations where we deliver our services, and what we do in each of those specific countries allows us to leverage the right sort of blend of consultancy, technology, and tools to deliver the best outcomes for our clients. Like this, but still focusing on higher education, is that we are able to easily leverage the learnings from each of our projects at our different client locations. To give you an idea of our commitment to higher education, we focus on supporting the Higher Education Strategic Planning Association in the UK and EDUCAUSE in the US. And as you can see, this is an example of one of the typical settings where we would give a presentation of our use cases like this. However, with the current situation, we're hoping that you get the same effect from this webinar. As you can see, we work with quite a wide range of both large and smaller size institutions, both government run and independent. And what we find is that everybody seems to have typical challenges built, silos that have been built up in the organizations. However, the typical language, the typical types of data, and the typical goals, which is to increase student headcount in a way that allows them to still deliver quality services and retain students from year to year. In essence, what we do is underpinned by four key pillars. The first is data enrichment and data consolidation, which is in essence getting our hands on the right data, making sure that it's correct, that it's of sufficient quality, and that everybody understands what the starting point of our planning lifecycle is. We then move on to data visualization, which is to leverage the data that we've just cleaned and got our hands on, and really deliver a quick insight through visualization tools. Beyond that, once we've understood what's actually happening at the moment, given the visuals will quickly give us an insight, we can start to look at forecasting and even predictive modeling, which is where our data science capability comes in. Following that, what typically happens is this is underpinned by data governance projects. The reason for this is that we want to simply implement a practical data governance framework that everybody can get behind and make sure that they're benefiting by using the right curated data sources for their analysis and sharing the insights that they have delivered through their analysis work, and in essence bring together these different silos of both data and team players. What we deliver in the higher education space is a simple yet customized set of tools and services that are, in essence, a fully self-service, but are brought together to bring a big impact on decision-making, planning, and collaboration within the organization. So as an example, you may have seen previously our student number planning solution, which is built on analytics in the Alteryx platform. We understand that data and a solid engine is at the heart of all the decision making within the organization. So as you can see, our solutions and services are geared around the types of data that you can, and the types of insight that you can leverage from things like doing student number planning. Because from student number planning, you can identify things like your KPIs, which then affect your league table position. Recruitment and clearing, so understanding how many students do we need to offer to in order to hit that student target, the income side of things, the potential for students to drop out, basically utilizing all the data to your advantage to make sure that you are performing in an optimized way. The point of looking at the data that sits within student number planning is we understand that everything that it hinges off of as well. So within all the different institutions that we work with, what we found is that after getting the heartbeat of student number planning modeling correct, what you can then do is start to answer other questions in a rapid and collaborative manner. And these are the key points. With the rapid change that, for example, this pandemic has brought, what we need to understand is, for example, how best to allocate rooms to account for example, social distancing. Which is, obviously very different to the situation we were looking at last year. We also need to think about things like how does adding or removing a course affect the demand on campus resources? Or how to allocate space when we're awarded a new research project halfway through the academic year. Beyond that, you also look at, well, who do we assign that to? So you then apply the same thinking and collaborative approach to teaching and research workload modeling, to the timetabling side of things, to looking at how many students we are going to have next year based on predicting the dropouts, and help people to understand what the most successful pathways in terms of module choices might be. But then how does recruiting more students make a change to our KPI, such as our student staff ratio, and then looking at how that will impact our position on league tables, how we can distribute workload between actual teaching and research, and how we can help departments to understand the impact of any changes they make with other departments. So hence, we're looking at sharing and collaborating across the whole enterprise and optimize across the whole institution in a very collaborative manner. So this is, in essence, what underpins how we work with universities and what's made us successful, and how we've been able to leverage the different use cases from our different clients to bring you some real impact use cases, such as campus utilization and optimization. So thank you for letting me give a brief introduction to Billigence and how we work. I'll now hand over to my colleague Iveta to give you an overview of the modeling approach.
So, hi everyone. My name is Iveta, and I'm from European part of Billigence, especially, in more detail from Prague. And as Michael said, I am the one who is going to be talking to you in more detail about our two use cases, about the campus space utilization and campus space optimization, or as I like to call it, allocation model. So let me just start the presentation. So give me a moment. Yes, hopefully you can see the presentation already. So as I mentioned, this talk is going to be basically divided into two parts. The first part will be about campus space utilization model, and the second part will be the campus space optimization or the allocation model. In both parts, I will be talking to you and showing you basically like the reasons you might want to have this at your university, or you might be interested in that. And so I'll try to answer some potential questions, and basically at the end there will be time for your questions. So let's go directly to the utilization model. And so basically, usually what happens is that some university come to us, but they don't come to us with the question, oh, please, can you do for us the utilization analysis? No, they come to us with a specific question. And for example, one of the specific question was, okay, hi, we are a big university and we want to actually know whether we need to build a huge 350 plus capacity lecture theater. And if we need it, we want to know basically why, what are the reasons that we cannot fit our students into different rooms, into different lecture rooms. And if we don't need it, again, where we can put our students, we need some reasoning to take to our board. So, this is the usually the case that some university come to us with a specific question, but some other universities may come to us with something like, okay, so we know we are not using the university, the campus space really, in the best way, but we don't know why, we don't know where the problems are. And our utilization model is something that it's supposed to help you understand what is happening and answer these questions for you, like, do we really need this huge theater to build this lecture theater, or do we really need to build another building? Or is it like that we are not using the space in the best way, so maybe we can save this money and put them somewhere else, like buy some new equipment into the rooms, basically to make our students more happy? Or is it like, okay, our students are not happy. Why are they not happy? The analysis may show you like, okay, they are not happy because, they are like traveling from A to the place B, and they have like 10 minutes to do it, and it's several like miles or kilometers away from each other. So you can come to us with specific questions, or you may come to us with we don't know what the problem is. We just know that there might be some issues with the utilization, with the way how we are using the space, but we don't know where the problems are. So other questions, or other problems which may come, to your mind are, during the spring, you're usually like planning the next semester or the next year. You know that you are like opening some lectures, some classes, say for 200 people, and you don't know that basically how many people really will be there. So you have to like book some room with capacity, say 200 people. Then, the autumn comes, the students actually enrolled in the classes, and you find out that there is just, say, 150 people. But you've already booked this huge 200 people room. So is it really necessary to use this room, or can we, take these students, shift them into a smaller room and use this huge room because, for example, you may decide that this is better than to use the external space, because, always like buying or paying for external space, it's super costly, it's not really good for the university, and you may find out that you are really using a lot of external space when you don't really need to, because you are not using your internal space in the best way. So basically, the campus utilization model is about cost avoidance. It's always about like saving you money and putting them somewhere where you can actually use them, in a maybe smarter way. So when I'm talking, about this like utilization, let me just very briefly like define what the utilization is or how it is being calculated. So the space utilization is a measure. It is a measure basically which is telling you how often and how much the space is used. So you might have heard about other two words, the occupancy and the frequency. The occupancy is telling you like how many people are actually using these like rooms with a certain capacity. So let's say that you have a room which has capacity 100 people. and the number of students which are being like taught there is just 50. That means that half of the room, basically half of the room, is not occupied at all, which makes this occupancy just one half or 50%. On the other hand, the frequency is telling you how often are you using these rooms. Say that you have a building, there is a room, and you have this room opened for 8 hours a day. And only in 4 hours of this day, the room is used for some lectures, which means that for other 4 hours, it's not used at all. And the frequency of your, the space usage is basically, again, just one half. So these are the occupancy and frequency, and the space utilization is just a product of these two. So basically just a multiplication of these two measures. So the space utilization tells you like whether and how the space is being used. So always what you want is to have the campus or the space utilization as big as possible, as close to this 100% as possible. Obviously, like 100% through whole campus is absolutely unrealistic. But if you get to like say 50-60%, that is super amazing. That is the number you should be like, like going to, like this is what you want. But quite often what we see is that the utilization is actually around 20%, sometimes 12%, and even if it's so small, the universities are still using external space because they're kind of like live in a world where they think that they don't have enough space. And there might be like a good point, to this, because they really don't have enough space in certain times. And this leads to like analysis of peak hours of the peak days. During the week, there might be some like more popular hours. Say, usually it's like Wednesday afternoon is really popular, but say Friday morning, no one really wants to get up on Friday morning and have this like go to lecture, or the professors don't really want to give lecture in the morning, not that because they're lazy, but because students don't want to go there. And usually what happens that after like few lectures, there is basically no one there. So this may lead to, okay, so we are putting everything into the peak hours, and then we don't have enough space, and then we need to pay for external rooms. So maybe the solution would be quite easy. Let's just take some of the lectures, the ones which we actually can move, and put them into different hour of the day, or different day if it is possible, obviously. And then you might not need to use the external space, and it might save you a lot of money. So what is like the output of our model is that we can give you dashboards which basically show you everything you want to know, like the frequency, occupancy, and utilization rates. It can be per faculty, per department. In certain building, you might be interested how this building is used at all. Is it reused? Then you might think about, okay, so this building is not really that much used. Why is that? And then you might find it's just too far away from other buildings, so there might be some need for shifting the classes which are happening there to some other classes. You might be interested in like, okay, so are we using our huge the expensive rooms enough? Why is this building not so used when it has the same owner, and stuff like that. Other output of this model can be analysis of something. You may come to us, as I already said, we don't know where the problem is. Can you do the analysis and tell us like where the problem is? And then obviously there would be like these dashboards you can play with yourself, and then also like some report. We think there might be an issue with this and that. You may think about this. There are some like weird numbers here, so you may find out what's happening there and why is this happening. Because when you have these like like these reports and these dashboards, you have actually something in your hands to take to the board or to the specific people and talk to them with not just, do you know where the problem is, but we know where the problem is. We need to fix it. So how are we going to do it? Other thing which you may want to do, and that really depends on what you have, is comparison of your teaching plan of the scheduled hours and reality. It means that some of the universities have like these sensors in the doors, like that people that go into the rooms, they're like being counted, and when they leave, they're like again the sensors know it. So what we were able to do is download the data from these sensors, and then like compare them with the scheduled plan. And what we find out is that a lot of scheduled lectures or scheduled events are actually not happening at all. And then you might go to the people who scheduled it and ask him, okay, so why did you schedule it when it was not happening? There might be reasonable, there might be reasonable why he didn't really why this event didn't really happen, but there might be something like, well, we wanted to make sure that we have something planned and stuff like that. And then there might be some, new way of like dealing with this for you. Another thing is that a lot of universities have like room divided into basically two categories. This like locally bookable stuff, like rooms, which basically belongs to the departments, and then centrally bookable spaces. And these departmentally bookable, these locally bookable spaces are quite often not used, because these departments are kind of like, okay, we are like leaving it not booked because what if we need it for this like last minute stuff. Then again, you may go to the proper owners and talk to them that it's not actually needed to use expensive external space when they are not using their own spaces. So basically, for the solution overview, so what we need from you, we need your data. Obviously, each university has different data, has them stored on different places. You may use different databases. You may use Excels. You may use some, for example, CMAS, which is something like this system for universities. You may have it stored somewhere on cloud or something, and we need to get this data from you. Obviously, this is a hard part, because not everyone knows where the data are stored, but usually after talking to your IT department, we are able to gather the data. When we gather them, then we do the transformations with them, because what we need. So we need what kind of rooms you have available, what are the capacities of these rooms, and then what we need are the scheduled events, where they took place, and when they were happening. So we need to kind of compare all of these data together, do the transformations, do the utilization calculations, and then the hard part is doing this analysis, this utilization analysis, doing these dashboards so that you can play with it and see everything and answer your questions. So what we are using in more technical detail is analytic platform Alteryx. We believe that Alteryx is the best tool for this, because from my point of view, from my personal point of view, it is super easy to use. When we will build your model, then after a year, you might be, okay, I want something to be changed there, and actually you can do it yourself, because Alteryx is easy and you will understand the model. It's not like a huge amount of code. It's just playing with some tools and putting them in the canvas. And I will show you Alteryx at the end of this presentation. So we think Alteryx is the best for you. Obviously, the dashboards would be in your preferred like visualization tool. We've put here Tableau because we are working with Tableau, but if you have Power BI or something else, it's obviously not an issue to do it in your preferred visualization tool. So these are some few examples of the dashboards. Please bear in mind that what we are showing you are not the real data, because obviously we cannot show you the real data of some university. So these are just like some demo data. And so what is this supposed to show you? So these are the frequency, occupancy, and utilization rates. In more detail, what we showed you here is the dashboard of occupancy by day and hour. And what you might see here, for example, okay, so this is on some on some as big level as possible, for all buildings and all rooms. And what you may see here is that, for example, Friday morning not so popular, Wednesday afternoon quite popular. And even this may lead to you, okay, there is an issue. There are some like huge numbers and small numbers, or Tuesday afternoon, and you may go to the more details and find out why is this happening. What is the building that is these like small numbers are happening? Why is it there? What are the rooms? What can we do to change it, to have it like more equal? Obviously, you can go into a different level, like different granularity. You may use just like some, you may filter just some room you are interested in. This is a dashboard which is supposed to show you scheduled and real rates comparison. Let me just focus here on 8 in the morning. These are the times 8 to 8:18. And again, it's through all rooms and all capacity category, but again, you can filter here. And for example, here you may see that in 8 in the morning the utilization is quite small, like 12%. Okay, so it's quite small, but what is the reason? And you may see that it's not occupancy, the rooms are being quite occupied, like the occupancy is not as small as you might think. But the problem is the frequency, because the rooms are just not used, just a few rooms are used, so the frequency is not big. So you might, go again to more details and find out where is the problem. Another one is only for basically those of you who know, who have these like sensors, or like the students have to log in somewhere, or some way of finding out whether this like event actually took place. So this is the comparison between scheduled hours and real used hours. So these scheduled hours, you can see for this one is just that the capacity of the room is less than 50 people. This is like the middle, like 51 to 100 people. And let's just stay here, and you can see like the comparison between scheduled and really used hours. So the question would be, why are we using just like over half of the scheduled hours? Why are we using really just this amount? What's happening? Why was it like cancelled? And this one is about, what is, which departments are actually using our external rooms. In this light blue, you can see that this is, use of external space. So in here, these two departments are using external space, while these three are not using external space at all. And you may see what is happening during, the terms, the semester. So again, you can go to the departments and ask them, why are you using it? And they may have very good reasons for it, but it's always good to be informed and to see, like, why are you spending so much money for it, and if it is reasonable. This is a quick look at how this model can look in Alteryx. I will not go to the details. I will show you Alteryx at the end with the other model. But just to kind of like summarize what's happening, we are calculating supply, which are, these available hours for each room. We are calculating the demand, which are like when these events are happening. Then we are kind of like putting everything together, and we are calculating frequency, occupancy, and utilization, and then we are exporting data. So what we did is that we changed this repetitive, long manual process. This because before you're using something like this, when you want to do some analysis and you don't have like some tool which is like putting everything together, you need to manually go through databases, through some systems, look at rooms, in like individually, but you do not see the big picture. You do not see it through everything. So every time you're doing an analysis, you're starting on this highest level. You are looking at it like from really far, looking at it, and then, okay, there's a problem. And then you are going into more details, into specific rooms, and like finding out where the problem is. So this is what will this model, this campus-based utilization model, allows you to do. And now I will actually go to the second model, and you will see immediately why we've decided to show you these two models together. So this is the optimization model or allocation model. And the important thing here is that this new model, this optimization allocation model, is basically an upgrade to your utilization model. So always, first, you need to know what is happening in your university in the sense of space usage. So you need to know what is happening. When you have this utilization model done, all of these utilization calculations done, get the data and stuff like that, then you can build on it. It is the natural next step is to use the allocation model, because in the allocation model, basically what it does is kind of taking everything you had from now and mixing it together. So what we are doing is that we know that you have a timetable already. We are not trying to, don't worry, we are not trying to touch your timetable, because, timetable is something universities are working on for usually years, trying to make it better. There are usually just slight changes to the timetable from year to year. And timetable is something sacred to the university, because some professors need to teach at some hours, and these courses need to happen at different times because they are the same students and stuff like that. So we are not touching your timetable. But what is actually changing year to year is the number of people which are enrolled in these lectures, in these courses. And since the number of people is changing, you need to, or usually you need to change where these events are happening, because what can happen is that this this lecture, suddenly it needs to be on the first floor because there might be disabled students which are not there before. This lecture needs a projector, it didn't need it before. This lecture needs to happen in a bigger room because there is more people. On the other hand, some other lecture, it doesn't have as much people as you would have wished for, and so it's not really reasonable for it to be happening in this huge room. So what we do with this is that we take your timetable as something which is fixed, and we calculate, we optimize where you should put the lectures, in which rooms you should put the lectures. So it is a room allocation model for events in your timetable. And we are trying to do it in a smart way, so that this it is optimal. And by optimal, I mean that your campus space utilization through whole semester or through whole year is as big as possible. These tables are supposed to show you like why we have decided to use optimization model. So like, why to use optimization? Some other approaches you may think of are like, okay, so doing it by hand. There is a group of people which are doing this timetable, and they are also allocating all the lectures into the rooms. That's perfect. Again, it works somehow. But when these changes come, usually it means that you should change everything in order to get your utilization as big as possible. So automatically you think of, okay, so let's use some algorithm. Some of you may think that taking these like lectures, which are the longest, longest in time, should be put somewhere first, and then like say that you have like 3-hour lecture, then you put it somewhere, then you have like 2-hour lecture, then you put it somewhere, and you're going like this way. But all of these approaches will never lead to an optimal solution. It basically it cannot do that. But the optimization is not like thinking in this way. It's just mixing it together and actually calculating what is the best, in the sense that the utilization is as big as possible, it's maximal. So in these tables, you can see 3 different scenarios. In first scenario, there is just really too few rooms. You don't have enough internal space, and you need to use the external space. These are like potential approaches you may use to, allocate these events into the rooms. And these are these rates. The utilization, obviously, utilization, you want to have it as big as possible. So this one means 65%. It's obviously better than the previous ones. And this is the ratio of not allocated events, meaning that you want this to be as small as possible, because this is like, the percentage of not allocated events. So as small as possible means spending less money for external rooms. And in all 3 of these like scenarios, there's like so amount of rooms, and this is like something that never happens. You have too many rooms and you never use external space. And even in these 2, the optimization always leads to the best results. To kind of summarize what this allocation model does, so it's similar as in this utilization. We are gathering the data. So we are gathering the timetable. What we need to know is the class size, the needed equipment, the needed features, location, whatever information you can give us. We need the room info, so room size, the actual equipment which is in these rooms, the features of these rooms. And again, we need to kind of like take it together, and for each event we filter only the appropriate rooms for each event. So if the event needs to happen on the first floor, we take every room which is not on the first floor and just throw it away for this event. So for each event we have just a few rooms which are even possible to use. Then we use the allocation optimization model, and then the timetable and room allocation is ready. Obviously, this is a process which can be done many times. You don't have to use it for every class and every room. You may say, okay, we are absolutely happy with this part of our timetable with the rooms, but we don't know what to do with this. This is something that changed. This is something that we don't mind that change, and play with this like allocation model and see the timetable. And you may do it as many times as you want to kind of like find what is best for you and your university. This is the example of the demand, what you need, this like how we are filtering these appropriate rooms. So You may have that this is in English class. It is happening on Wednesdays, on some weeks, on some times. You need a room with capacity 100 people, so 100 people and more, obviously. You need there to be a whiteboard and projector, and needs to be first floor or elevator or just no stairs. So these are the constraints. We call it constraints, which you put into the model, and you usually know this stuff. We put them into the model, and it will find you the appropriate room where to put it so that the utilization is as big as possible. So what is the idea behind the optimization? First of all, what we are using is something we called linked events. Linked events means that, if you have like a history class, we cannot ask students to, each week go to a different room. It would be good for the model because, if we would could, have events happening in different rooms each week, it would be good because we could then, schedule these not really periodic events in a best way. But no, we definitely cannot ask students to do that. So we are linking these events together so that these classes always happen in the same rooms, and students are happy and not angry at us. So that's the first thing. And a little bit of mathematics behind this. It's what we are doing is mixed integer programming, and we are using again Alteryx and in more detail Alteryx prescriptive palette, the optimization tool, which is where all of this like magic or stuff is happening. So just kind of to summarize. So first of all, we are gathering the data from you, preparing them. Then we are creating variables, calculating the utilization. We are creating some sparse matrices with the constraints. These are these like whiteboard and projector and first floor. Then we are doing the optimization calculation, and then there are some results. And obviously this like changing these constraints, you may do it many times and see the results as many times as you want. And this is my cue to actually go to Alteryx. This is just a picture, but I will actually go to Alteryx. I hope you can see Alteryx. So this is Alteryx. It is an analytical platform where you can take tools, and in a super simple drag and drop tool, drag and drop away, you can build your own, we call it a workflow, where like this this logic is happening. What is great in Alteryx is that you can always see what's happening where. So just quickly, I will just zoom in slightly. These are the inputs, and this is where we are gathering the data from you. These are this part where you can like see the lines, where is it going, in which tool it is going. So you can obviously immediately see that we are gathering the events and rooms together in here, because these two lines are kind of joining here. And this part is where we are preparing the data, where we are like doing some of these transformations, the basic calculations and stuff. In here, this huge one is where we are creating this like matrices, this mathematical stuff we need for the calculations. And this is part which is basically fixed. We know how to do it, because usually this first part is changing because you have different data, but this is where the preparation for the calculation is actually happening, and this is where the magic itself is happening. There is this like optimization tool from Alteryx, and you can see it has several like inputs that's going there, and this is what is showing us the results. Obviously, if I just scroll down, there are some like other calculations. There are some like visualization stuff, like what we want to know, what we want to compare with itself. So this is Alteryx, and at this point, this is all from me, and I would like to hand it over to Colin. Thank you.
Hi everyone, my name is Colin from Diligence Asia, and I want to thank Iveta for that wonderful presentation. Before we wrap up the webinar, I would like to open the floor for any questions you may have throughout all of our content. So if you see a little speech bubble with a question mark, do press it. This allows you to publish any questions you may have onto the webinar itself. Now, as we head into the Q&A session, let me just present my screen. So with that, I'd like to iterate that the campus optimization and utilization model were all built on the Alteryx platform, which is recognized as a leader with the highest ability to execute according to Gartner in the 2020 Magic Quadrant for data science and machine learning platforms. And when you really look at Alteryx, it is this modern end-to-end analytics platform that allows you to do any part of the analytics lifecycle. And this is what we really tried to show during our demo today. We went from basic reporting to empowering organizations with a full understanding on how the resources have been utilized. This then is followed on by our optimization model, which allows you to cater for a different range of scenarios, as well as predict how the different scenarios will impact upon your resource allocation plan. Now, with that being said, let's head over to the questions. We had quite a few during the session today. One of the first questions we had was, can student number planning model adjust for social distancing requirements? Iveta, do you have any experiences on that?
Speaking about student number planning, maybe I will answer a bit different question, whether the utilization and optimization model can actually help, and then we can go back to the student number planning. The social distancing, what you can do is you have a lecture room which has a capacity of 100 people, and since there must be this like social distancing, there must be like some free room around you, so you cannot definitely put 100 people there. But what you can do is change the capacity of these rooms, not to like 100, but it can be like 25 maybe people can put fit there. So you change this capacity of these rooms, run the model again, and then this problem is basically solved. So, but it needs your help with the capacities of the rooms. Concerning this student number planning, well, the student number planning model is kind of like telling you what we think, or what is the possibility of how many people will be there next year. So there might be some changing during this like COVID situation. Maybe not as many people wants to go to study, but it's not really going to help you with this social distancing stuff.
Yeah, thanks for that, Iveta. And just building onto that, when we look at social distancing as a business problem to solve, it's quite similar to the way you would try to do resource allocation for exams. As we know, during exam periods, you'll have all your students being allocated into the same room for a certain period of time. And so what you can do with social distancing is apply what we do for exam room allocation, where some universities may need to book external venues, and apply that using social distancing rules. And so that's just one of the use cases that we'd like to answer from the questions. Now, we had a series of other questions. One from Vinithra, which is, can you provide near real-time utilization rates and notifications? How powerful is this tool?
How powerful is this tool? Well, it depends what you are asking and what your problems actually are. But mainly, for example, when I was talking at the beginning of this like university, which was asking whether they need this huge 350 people theater, they wanted to spend over £2 million on this, and they really didn't need it. So they saved this amount of money and put them somewhere else, somewhere, I would say, more smartly. So I think that it's pretty powerful tool, because it allows you to ask the correct questions, make decisions on it, and then, for example, using this optimization tool allows you to correct the wrong decisions which were made before.
And with that, another question we had was, the model uses census data, right? What else can we use to replace the data input?
This model doesn't actually have to use the sensors data. You know, the sensors data are something like, again, an upgrade because it tells you the real usage of your campus space. But you may, you know, you might be interested in that, but you don't have to. But in case that you really want to know this part, you can see like there might be in some lectures students might have to log in. What you might do is to have like paper, you know, pen and paper, you know, people signing on their names is probably the cheapest way how to, you know, find out if these events were happening and how many people are actually going there. So you may go to the cheapest way, pen and paper, or you may install some sensors, or maybe you will find some other way how to find this data. But actually you don't need it for the utilization itself. This is just like one small part of it.
Yeah. So if you have anything to do with attendance data, all of these can be utilized in the model to try and figure out what is the best way to allocate the best room to the right number of students. And talking about implementation, we have two questions, one from Lynn and one from Anonymous, on how long did it take to implement this solution and what are the real big success stories that we've had using this model? Maybe I'll pass the question to Michael Evans.
Thanks, Colin. So in terms of the first, how long did it take to implement? The first element is actually just getting their hands on the data and producing the model in Alteryx to clean the data itself. So it depends. You know, typically what we find is getting the data in the right shape to be used is where the real challenge lies. Once you've curated that data set, it's super quick, right? Because you're using a tried and tested approach. So, you know, again, I'll caveat it. It may take, you know, a couple of weeks initially just to make sure you're operating from a clean data set and to set up that process of pipelining regular data to you so that you can make, you know, in-week or in-semester changes. But then once you've done it, the production of the model is almost, you know, a lot of it is pre-canned and it's a tried and tested approach. So therefore, that aspect could take another 10 days. But once you've done that, it's then just maintaining that model and obviously utilizing it. From the second question was the biggest success story. I think with one of our London-based institutions, rather large institution, they were spending almost £2.5 million externally per year on teaching space. This teaching space was literally short notice teaching space from external hotel conference facility providers. Now, of course, central London, you know, high rates, etc. So, you know, you've got to consider whether, you know, you're in a location where you'll be paying premium for this sort of space. But what we helped them to do was avoid the costs of these last minute expenditures with third parties and help them optimize the use of the space. So that, in one sense, helped them to avoid from an OPEX perspective, and it was obviously all unplanned money. They just had a budget because they knew that this problem is a recurring annual problem. So from one perspective, it helped them from an OPEX savings. Second, because we helped them to understand what the lack of real business case for building a 350 plus attendee lecture theatre was, we helped them to actually inform their capital development plan and realize that, well, actually the best use of our money is not to build this lecture theatre that may only have sort of 2 or 3 sessions a week in it. We're better renting that space and then, you know, leveraging where we actually have the real need. So building more of the 50 to 100 size lecture theatres. So it really helped, you know, in 2 main ways. One, to inform their capital development plan, and second, to avoid operational costs, which they could then reinvest that money into the student experience and upgrade their buildings, of course. But that, again, is just another area of how to reinvest everything you can save through utilizing this model.
Thanks for that, Michael. And just adding on a little bit more context to implementation, for the campus utilization and also optimization models, those were all built with Alteryx Designer. So what that means is using Alteryx Designer, you can drag and drop certain data transformation tools into the workflow itself and be able to quickly adapt to a range of scenarios or parameters that is specific to your own organization. And this entire process end to end, after you clean the data, after you validated the model, will only take about 1 month to implement for a standard customer. And now we're just about on time. There's one last question from Margaret, which is, in their case, they have the data, but they don't know where it is. What is the first step they can take towards having a campus utilization model? Iveta, would you share insights there?
Yes, of course. First thing that we always do is go to your IT department, talk to them, and you don't know where the data is, but they need to know where the data is. They may not know which of the data we really need, but if they lead us to where the data are stored, the cloud, the databases and stuff like that, it's their job to know, then we can find out what we actually need and use it. So I wouldn't really worry about that they don't know where it is, but there might be a slight issue with the quality of the data, but that's again our work with the IT department to clean the data and get what we actually need. So the first step is definitely going to the IT department.
Thanks for that, Iveta. And with that, I want to thank everybody for asking the questions, and I will now hand off to Vignesh to close out this webinar.
Thanks, Colin. Thanks, everyone, for giving the answers to all the questions that were asked. I think we had a good range of questions. Thank you so much for joining us on this webinar. I hope you found Iveta's presentation on campus utilization and campus optimization helpful to ensuring your institution's assets are used to optimum capacity. I think in some instances, this would be a source of revenue generation as well, especially for the private schools. If these are use cases, if they actually address some pain points you may have experienced in your organization, we're happy to catch up with you after this webinar. Do watch out for our emails to schedule follow-up calls with us, and you can also review a recording of the session we just had. If you have any questions that may not have been addressed or we haven't had time to answer yet, please do write to us. We'll respond as soon as we can. Thank you and stay safe.